Continue from yesterday. Okay. Um, can you hear me clearly, everyone?
Yes, teacher.
Okay. Yeah. So we can continue. So yesterday, um, you have tried this exercise 4.3.2, about these two models, two classification model. So you can see just by looking at the hypothesis, you can see that the first one, uh, because we use this as a decision boundary, so it is a linear decision boundary, right? So for hypothesis number one, it works if the data is linear separable. And for the second one, uh, yes, the boundary is not linear. You can see this is an equation corresponding to an oval. Yeah, so it is an oval decision boundary. So yes, we can try to. Okay, so let's first try to plot the data so that you can see like what is the structure of the data, and just by looking at the structure of the data, you can see like which one should work between these two hypotheses. Okay, so probably I can. Okay, I can make a copy from this one. Okay, so let's call it 4.3.2. And actually, I can borrow some code about visualizing the data from the machine learning class. Probably from this one. Oh, not this one. This one probably. Okay. All right. So I will add one block here. Okay. So this is the old code from 4.3.1. So the first function, we can keep it the same, just to extract data from a CSV file. So let's try to upload the dataset file into Google Colab. All right. Okay, so for this data set, we have 200 examples. So now let's try to plot a graph visualizing the data. So I think we can use matplotlib. I think it is okay. Okay, maybe I can delete everything here. Yes, so let's try to Okay, so let's try to convert it to NumPy first, because here you should, yes, for the, so is everyone already familiar with the Matplotlib? I think you used to use it in MATLAB. No, it is very similar to what you have done in MATLAB. Oh, it's okay. So yes, so this is a library in order to draw a graph or to visualize your data. Okay. Yeah. So we can import this library, and you can see here we have this in order to plot like each example as a data point. So, and the data here, it should be a NumPy array. And you can see here our data, it is just like it is a Python array, so we have to convert it to NumPy first. So maybe I can import NumPy as well. And then is equal to, so we use x1 as the horizontal axis. Okay. H1. And for the vertical axis, we use x2. Okay, and here we can plot the xx and here yy. Okay, yeah. Okay, so let's try to run it. Hope it is okay. Yeah. So here's the data. Here's our data. Okay. So so let's try to put the color as well to see. So maybe we can like assign a red color to the examples belonging to the positive class and the blue color to the negative class. Okay, so probably we should do something like okay, something like this. The bell is equal to np.array y. And here we can do something like bells equal to 0. All the negative class, we assign blue color. And we plot another group of data points. And this one is for the positive class. And we change the color to red instead. Okay, so here, you see? So the red points correspond to the positive class, and the blue points correspond to the negative class. And you can see that this kind of data with this structure, it is not linear separable. We cannot like draw a line in order to separate the positive and the negative class. So if we look back at our exercise, it is not possible that we can use the first hypothesis to be like a good classifier for this data set. And you can see that the second one, it is an equation of an oval. And according to the structure of our data, you can see it is perfect for this data. It can be like a circle or an oval in order to be a decision boundary to separate this data. All right. Yes. So if you train your model correctly, you will see that the first model, the first hypothesis, will not produce a good accuracy rate. But for the second one, it should be very the accuracy rate for the second hypothesis, it should be very high. All right. So so let's try to build the two models together. So we can keep everything, right? The hypothesis, the hypothesis, this one is the cost function. It should be okay as well. So maybe I can put in some comments to yes, to show like so T8, this is a tensor m by n, right? So n is the number of input features. And it includes H0 as well. Right? Yeah. And then T8, it is a tensor as well. And it should be n by 1, right? This is the dimension of our parameters. And for the cost function, Tz, it should be tensor of m by 1. And Ty, it should be tensor of m by 1 as well. Okay, yeah. And this one, it should return tensor m by 1, right? Yeah. Okay, yeah. So so let's try to build the first model first. And actually we have to do multiple training. So probably it is a good idea to define one function so that we can call it to train our model. So let's call it like train model. And here I think what we can do, because the difference between the two is that you can see that for this one, what we can do for the second hypothesis, we can convert like h1 square and create a new feature. We can call it like h3. So h3 is equal to h1 square. And the same thing for h2 square, we can get a new feature as well called h4, which is equal to h2 square. So now you can see that it is just like a linear decision boundary. Just that h3 and h4 is equal to h1 square and h2 square respectively. Okay, but we can like do the same thing as just like h1. Just that in h1 we have only two input features. If we count also h0 here, we have 3, right? We have 3. And for the second one, we have up until 5. So if we look at the code again, it should be all right for our hypothesis here. We can just use different input. So here, maybe I could just call for T8. Yeah. And again, here, the Tx that we pass as an argument, it is a tensor m by n, right? N is the number of input features, including h0. All right. So first we should create our parameters. So I can copy from here. Okay. So we create our parameter th, and the dimension of our parameters, it should like here. The number of parameters, it should be equal to here n, right? So let's first try to get the value of n. So it is equal to th dot psi 1, right? Again, this we have 2 dimensions, and the index start from 0. So this is dimension 0, and this is dimension 1. Right? We would like to get n, so we can just call the function size of Python. This one, we can use it as a method function for as a class method of a tensor. Okay, yeah, and here we can just specify which dimension that we want to get. So we get n. So here we can use n instead of 3. And here it is a tensor n by 1. All right. And then we, just like before, we modify the requires grad attribute of our parameters tensor to be true, because we have to keep track of the gradient of this tensor. And what's next? Okay, maybe I can copy everything here. Okay, so we define our learning rate. And then maybe here I can also like in iteration because of when we want to train our model, we can use this function and then we can specify the number of iterations here. Okay. And also the learning rate as well, probably. So alpha is equal to 0.1. I can remove from here. And here it should be an iter. All right. This one is okay. This one is okay. This one is okay. And then we print to see if it decreases or not. And then we update the parameters. Okay. And at the end, after the training, we can just return like the parameters. So we return the parameters, which is a tensor n by 1. Okay, so this is the function in order to train our model. So now let's create our data, the input, right? We have to have 2 different inputs. So this one, and we have T1, TH1, TH2, and then TY. Okay, and we have TH0. So right here, first TH for H1. Okay, for H1, we have to do the concatenation between these 3 vectors. So what we have is m by 3. And then we have TH for H2. Similar thing. But now we have to do the concatenation between TH0, TH1, TH2, TH3, and TH4 as well. And here the dimension is m by 5, right? Yeah. We don't have TH3 and TH4 yet. And again, TH3, it is a square of H1. And for H4, it is a square of H2, right? So here we can just do something like TH3 is equal to tau dot square. We have this function of TH1. And TH4, it is a square of TH2. Okay, yeah. So I can just remove everything here. And I can just write something like here. This is maybe print. Training model H1, right? And here we can just call the training function, the train model function. So T8 for H1 is equal to train model T8 for H1, right? And here we can also print training model H2. Call the function train model again for H2. And I think that's it. So let's try to run to see if there's okay. All right. So probably we shouldn't print every iteration. Probably it is better to print every like 50 iteration. Okay. So here is our training. So what happens here? Any idea how to improve it for both of the training? So you can see that the training for H1, the cost decreases, but it decreases very slowly, you can see. But for H2, you can see that it like become like a NaN here is not a number. So probably it is like too big that it can be represented, or maybe it is also too small that it can be, but if it is too small, it will become 0, right? So probably this is because it is too big. It becomes too big after, the cost becomes too big after 50 iterations. So what can we do to improve the training for both of the models here, for H1 and for H2? So for H1 first, what can we do? Probably it is easy, right? We can just, maybe the learning rate is too small. So probably we can increase the size of the learning rate. So by default, the learning rate is 0.1. So maybe we can use 1 instead. Okay, when we use 1, it become not a number as well. So maybe 5. Okay, so this one is a bit better. 0.5. So maybe 0.5 for H1. And what about H2? H2, probably it is too big, right? So maybe we can use smaller, maybe 0.01. It is not good because maybe even smaller. Okay, even smaller probably. So I think this one might be too small. Maybe 0.005, I think. No. This one, you can see that the cost decreases, but very slowly, just like before. So probably, yeah. So it's okay now. It works, right? So we can try to improve the training later. So let's try to evaluate our model. Probably I can define one function in order to evaluate the model. So let's if eval u8 probably like accuracy, because we would like to compute the accuracy. So maybe t z and ty, right? And what we want to do here is right here. And we can return this one directly. Or maybe we can return the value. So maybe this one I can change the name to ACC and ACC.item. Like this. So this function will compute the accuracy rate. So we compare the predicted output TZ here with the real output TY. Okay, so probably we can do something like again TZ for H1 is equal to TH for H1 and then TH for H1. And TZ for H2 is equal to H of TH for H2 and TH for H2, right? And then we can just compute the accuracy rate for H1 is equal to accuracy between TZ H1 and TY. And accuracy rate for H2 is equal to accuracy TZ H2 and TY. And then we can just try to print accuracy for H1 and for H2. So here it is ACC H1 multiplied by 100 and ACC H2 multiplied by with 100 as well. Okay, yeah. So let's try to run it. All right. So you can see here the accuracy rate for both of the models here. Okay, so we have H1 and H2, and the accuracy rate is not good at all because it is 50%, and it is expected for H1 because H1 is a linear model. The decision boundary is linear, so it is expected that the accuracy rate should be like this. But for H2, you can see that H2 it should be like the accuracy rate should be high. But here you can see that it is only 47%, which is not good at all. So what is the problem here? So we won't be doing anything for H1 because we know that no matter how we try to improve it, it won't be good enough because it is not a correct model for our data. But for H2, how can we improve H2 here? And any idea? You can see that the training is not very good as well because at iteration 0 from the start, the cost is like around 0.69. But after like 500 iteration, it is like 0.69, like not decrease a lot. So what is the problem here? Actually, it is similar to the first example that I show you. The first linear regression model that I show you, like when we have only two parameters A and B. You can see that we have to change, like we have to use different learning rates for both parameters so that when we update the parameters, we have to use different learning rates. Do you remember the first model, the first linear regression model? Any, so how can we improve it? So actually, here we haven't applied yet actually the concept about feature scaling, right? Because for this one, we should apply it when the input features of our data are in different scale, are in different range. And you can see here for hypothesis number 2, you can see that we have two new input features, right? H3 and H4. And H3 and H4 is the square of H1 and H2. So the range for H3 and H4 is very different from H1 and H2. Right? So it might be a good idea to apply the feature scaling here. All right. Yeah. So how can we apply the feature scaling? Yeah. So we have to replace each input with this expression instead. Okay, so we subtract the mean and then divide it by the here the standard deviation of the features, or probably just simply by the range. The difference, sorry, the difference between the maximum and the minimum value of that feature. Okay, so maybe we can use this one. It is much simpler. And so in our code, probably I can define one more function called scale. And the input is txj. Only one features. Okay, so txj here it is txj here it is tensor m by 1, right? Because we use only one features at a time to do the scaling. And what we return from this function, the same dimension, m by 1. Okay, and what we do is just return txj minus the min. So we can just call the min function. So each tensor we have this class method min in order to compute the min of all the elements in this tensor, and then divide it by the range, right? The difference between the maximum and the minimum. So we can also call txj max minus txj min. And that's it. This is the feature scaling. And before we do the concatenation, it is a good idea to do the scaling. Okay, so here I can call it a feature scaling. So th1 is equal to scale th1, th2 is equal to scale th2, th3 is equal to scale th3, and th4 is equal to scale th4. And then we do the concatenation just like before. So right now, let's try to, okay, so maybe we can change the learning rate to 0.1, just like before, and try to train again. Okay, maybe it is, let's try like open. Maybe this one 1. Okay. So 10, it increase just 1. And then maybe we should increase the number of iterations. Maybe to like 2000, I think. Okay, and let's try to evaluate again. All right, so you can see. Now, like H2 is like 100% accuracy rate. Okay. So let's try to like visualize the decision boundary. Maybe I can also like copy. And I can copy this code here to visualize the decision boundary. Okay, we can change the code a bit in order to okay, maybe I can something here TMP instead, and this one should be TMP and TMP. Or maybe what could we just like this? It's faster. And this one is X8, this one is X8, and underscore YY. This one is YY, this one is YY. And underscore and underscore. And HY is equal to underscore, this one underscore as well. Okay. And then that is the one that we have to predict. So we can use the second model here. So yes, so write something like Z is equal to H tensor X, Y. So we convert this one to tensor so that we can use it in our hypothesis. The type is equal to float 32. And then we have our, oh no, we have to because right here we have to create H3 and H4 as well. So for x5 you have okay, so I think yes, yes, I can share you the yes because I don't want to waste time here. We can visualize later. So yes, okay, delete this again. Yeah, so right here, yeah. Yes, after we will see that the decision boundary should be like between these two classes, right? I will, yes, implement the visualization code and then I will share you later. Okay. So now just that it works for the training. So we apply feature scaling and we train longer. We train with more iterations for the second model. All right, so any question?
Tôi lúc cũ currency របស់ H2 ហ្នឹងវាលោតដល់100វាមានន័យថាមិនដែរ
បានន័យថាអាហ្នឹងវា perfect accuracy rate ហ្នឹងគឺយើងចង់ដឹងថាតើ model របស់យើងអាច predict ថាវា data ដែលយើងដាក់ចូលហ្នឹងវាត្រូវជាមួយនឹង class របស់វាអត់អានេះគឺវាបានថាយើងមាន200 example វា predict ត្រូវទាំង200 example ហ្នឹងចឹងបាន accuracy rate វា 100%
បាទលោកគ្រូបើសិននៅក្នុង real practice តើវាអាចលោតដល់100ចឹងដែរអត់លោកគ្រូ
អត់ទេដោយសារនេះតាមពិត real practice ក៏គេអត់ធ្វើអញ្ចឹងដែរ actually in the real application we do not do like this because like right now what we do is that we train with our data, right? We train with our data and we evaluate with our data as well. So it is not really a practical thing to do. It is just like I don't know if I already mentioned this. It's just like that. If you teach if you teach your students during class, you give some practice exercises for them, right? And then you during exam you give the same exercises. So it is not like a good way in order to evaluate the performance of your students. So in the real application, in practice, usually we divide the data. We divide our data set into two subsets. We call them one is the training set and another one is the test set. And during training, we provide to our model only the training set, only the data from the training set. And then during the testing to evaluate the performance of our model, we use the test set instead. So the model haven't like seen the data in the test set yet. So if it can do good, if our model can do good on the test set, it means that our model is good. It can generalize well to the all of the data. Yes. Okay, yeah. Any other question?
លោកគ្រូខ្ញុំអត់សូវយល់អារបៀបធ្វើមិនដើម្បីវាបានអា security នឹងកាន់តែល្អលោកគ្រូ
accuracy accuracy ហ្នឹងគឺចង់សំដៅអាហ្នឹងគ្រាន់តែជាឥឡូវจะស្គាល់ថាស្អីទៅជា accuracy rate ហ្នឹងទេព្រោះអានេះវាជា classification problem អញ្ចឹង accuracy rate គឺអ្វីដែល model របស់យើង predict ហ្នឹងគឺជាចំនួនដែល model របស់យើងចំនួន data ដែល model របស់យើង predict ត្រូវចែកឲ្យនឹងចំនួនសរុបអញ្ចឹងយើងមានទាំងអស់200 example ក្នុងកន្លែងនេះ ចឹងក្នុងករណីដូចជា accuracy rate សម្រាប់ hypothesis មួយនេះវាប្រហែលជា 51% ហ្នឹងអញ្ចឹងបានន័យថាខ្ទង់ពាក់កណ្ដាលវាទីត្រូវខ្ទង់ពាក់កណ្ដាលហើយទីខុសពាក់កណ្ដាលដល់ពេលអាទី2នេះ 100% ហ្នឹងបានថាទីត្រូវទាំងអស់តែម្ដងហើយដែលសំណួរតាក់ទងជាមួយថាធ្វើម៉េចដើម្បី improve performance នៃ model ហ្នឹងអាហ្នឹងដូចតែអ្វីដែលខ្ញុំបាន diagnosis មិនមុនហ្នឹងចឹង so in order to improve your model the first thing that you can look at is if it learns correctly or not. So you can see that if it learns correctly, the cost after each iteration, the cost should decrease. Okay, yeah. So yes, after our final setting here, you can see that both the cost of the H1 and H2 decrease. So it is a good sign. Yeah, and if it decreases, it should decrease not just a little bit. It should decrease by like a large amount after some iterations. So you can, if we compare like the training of hypothesis 1 and hypothesis 2, you can see that for H1, the cost decreases, but not very much. It decreases only a little bit. And for the second one, you can see that it decreased from 0.6 until 0.5. So it decreased a lot more. It decreased a lot more, yes. It decreases a lot more. Does that answer your question? គេចឹងខ្ញុំបាទបញ្ចូលជាខ្មែរម្ដងទេកន្លែងហ្នឹងគឺហេតុអីបានខ្ញុំអត់ទៅមើល H1 ហ្នឹងទៀតអត់ improve H1 ទេដោយសារយើងមើល hypothesis សម្រាប់ H1 គឺ decision boundary របស់វាសមីការចឹងយើងដឹងហើយសមីការហ្នឹងជាសមីការបន្ទាត់ទៅដោយសារជាសមីការបន្ទាត់ decision boundary វាក៏ជាបន្ទាត់ដែរហើយដល់ពេលយើងសាក visualize data របស់យើងទៅគឺអញ្ចឹងយើងមើលមើលធ្វើម៉េចយើងអាចគូសបន្ទាត់ដើម្បីទៅ separate អាពណ៌ក្រហមហើយពណ៌ខៀវហ្នឹងបាន it is impossible យើងអាចមានបន្ទាត់ណាដើម្បីទៅ separate អាពីរ class ហ្នឹងបានទេដើម្បី separate បានតើតែអា decision boundary របស់យើងរៀងដូចស្តៀងរង្វង់តែដែលយើងគូសដើម្បី separate វានៅកណ្ដាលចឹងអញ្ចឹងហើយបើសិនជាយើងមើលទៅលើ equation របស់យើងវិញសម្រាប់ hypothesis ទី2របស់យើងនេះអានេះហើយគឺសមីការរង្វង់សមីការ oval មិនចឹងអញ្ចឹងបានន័យថា H2 នេះ it is possible that it works សម្រាប់ data របស់យើងហ្នឹងចឹងហើយនៅក្នុងពេល training នេះយើងសាកល្បងបដូរ configuration មួយចំនួនដូចជាយើងបដូរមុនដំបូងដោយសារយើងអត់ប្រើ feature scaling ដោយសារយើងមានfeature ថ្មី x3 x4 នេះគឺដោយសារយើងយក x1 x2 លើកជាការ៉េមិនចឹង scaling វាខុសគ្នាអញ្ចឹងបើសិនជាយើងអាចអ្វីដែលយើងអាច improve បានយើងអាចធ្វើឲ្យ scaling វាដូចគ្នាអញ្ចឹងយើងប្រើ feature scaling បន្តមកទៀតយើងសាកល្បងជាមួយនឹង learning rate មួយចំនួនទៅយើងឃើញថាដូចជា 0.1 ហ្នឹងល្អជាងគេហើយសម្រាប់មិនសិនជាមួយ1ណា1វាលះជាងវា decrease លះជាងសម្រាប់ cost របស់យើងហើយបន្តមកទៀតយើងឃើញថា500 iteration ដូចជាតិចពេកអញ្ចឹងក៏យើងបន្ថែមទៅដល់2000 iteration ព្រោះយើងមើលទៅឃើញពី0ដល់500ហ្នឹងឃើញវានៅ cost ហ្នឹងវានៅតែចុះវានៅតែអាចចុះបានវាអត់ទាន់ធ្លាក់ទៅដល់កន្លែង minimum របស់ cost របស់យើងហ្នឹងចឹងទៅក៏យើង continue to trade តែប៉ុន្តែទៅត្រឹមតែ2000ហ្នឹងក៏មិនទាន់ចូលអស់ដែរវានៅចុះទៀតវានៅ continue to decrease អូខេបាទហ្នឹងហើយអញ្ចឹងមាន any other question
អញ្ចឹងខ្ញុំ ចំណុចហ្នឹងក៏ខ្ញុំចង់សួរលោកគ្រូទៀតថាមុនដំបូងដូចលោកគ្រូតេស្តទៅមិន H1 ហ្នឹងដូចវាធំជាង H2 ដូច H2 ដូចតែ40%ជាងអញ្ចឹងទៅលោកគ្រូថាធ្វើម៉េចដើម្បីវា improve ឲ្យបាន H2 ឡើងទៅ100%ដែលវាធំជាង H1 ណាលោកគ្រូអាហ្នឹងយើងមើលមិនបានយើងអាចដឹងថាតើប្រើអាហ្នឹងបានវា improve ណាលោកគ្រូ
ណែដូចខ្ញុំនិយាយមិញចឹងបែរថាដើម្បី improve បានយើងមើលទៅលើ cost របស់វាពេលដែលយើង train ហ្នឹង cost របស់វាចុះអត់ចឹងដូចពេលដែលយើងអត់ទាន់បានធ្វើមិនហ្នឹងគឺ cost របស់ H2 នេះដោយសារ H1 គឺខ្ញុំ ignore ចោលហើយដោយសារយើងដឹងថា H1 គឺអត់អាចទៅរួចទេដើម្បីវាgood ព្រោះវាជា line decision boundary តែបើសិនជាយើងអត់មាន information ហ្នឹងទេយើងត្រូវ try to improve ទាំងពីរហ្នឹងតោះហ្នឹងកន្លែងហ្នឹងហើយដល់ពេល H2 យើងមើលទៅមុននឹងយើងប្រើ feature scaling ហ្នឹងយើងឃើញថា cost ហ្នឹងគឺវាចុះដែរប៉ុន្តែវាចុះតិចអញ្ចឹងបើសិនជាចុះតិចអញ្ចឹងបានន័យថាតើតែ learning rate របស់យើងហ្នឹងវាតូចពេកយើងអាចថាដាក់ឲ្យធំតែដល់ពេលខ្ញុំស្រែធំទៅវាទៅជា fluctuate ឬមកក៏វាទៅជា cost ហ្នឹង increase វិញអញ្ចឹងបានន័យថាវាមិនមែនមកពី learning rate ទេអញ្ចឹងมันអាចមកពីបញ្ហាផ្សេងអញ្ចឹងហើយបានយើង try to យើងព្យាយាមប្រើ feature scaling នេះចឹងដល់ពេលយើង try feature scaling ហ្នឹងទៅឃើញថាវាចុះអូខេហើយប៉ុន្តែដល់ពេល500 iteration ទៅវាអាចថានៅចុះទៀតតោះហ្នឹងហើយអញ្ចឹងក៏យើងបន្ថែមចំនួន training iteration ឲ្យច្រើនជាងមុនចាហ្នឹងជាចំណុចដែលយើងអាច configure បានទាំងចំនួន iteration learning rate អីហ្នឹងអាហ្នឹងសុទ្ធតែកែទៅជា hyper parameter ជារបស់ដែលយើងអាច fine tune បានហើយរបស់ហ្នឹងគឺយើងអាចដឹងទុកជាមុនទេតើតែយើងអាហ្នឹងគេថាធ្វើតាម trial and error អាហ្នឹងជា concept របស់ machine learning ហ្នឹងអាហ្នឹងគឺតើតែយើងធ្វើឲ្យច្រើន experiment អញ្ចឹងយើងសាកល្បងទៅ experiment មួយហ្នឹងយើងសាកល្បង configuration អញ្ចឹងជាទូទៅគេត្រូវមានគេថាមាន evaluate មួយទៀតគេធ្វើចឹងហើយគេ evaluate មើលទៅថា performance វាមិនដែរបើអត់ត្រូវទេគេ change អាហ្នឹងគេ change learning rate គេ change ចំនួន iteration ហើយគេ evaluate ម្ដងទៀតអញ្ចឹងគេធ្វើចឹងច្រើនដងទៅលុះត្រាតែបានជា setting ណាមួយដែលវា produce the best result ហើយដូចខ្ញុំនិយាយមកអញ្ចឹងជាទូទៅគឺគេអត់ evaluate នៅលើគេថាទិន្នន័យដដែលអញ្ចឹងទេគេត្រូវចែកជា subset ផ្សេងគ្នាទិន្នន័យដែលយកមក train ហើយនិងទិន្នន័យដែលយើងយកមក evaluate ហ្នឹងត្រូវជាទិន្នន័យផ្សេងគ្នាអាហ្នឹងបានយើង make sure ថា model របស់យើងហ្នឹងគឺវាល្អពិតមែនអានោះដូចខ្ញុំឲ្យឧទាហរណ៍មិញតើតើជាមួយនឹងយើងបង្រៀនសិស្សអញ្ចឹងណាបង្រៀនសិស្សបើសិនជាយើងយកលំហាត់ដែលយើងធ្វើក្នុងថ្នាក់ហ្នឹងយកទៅដាក់នៅពេលប្រឡងអញ្ចឹងប្រកាសជាសិស្សបានបន្ទុកច្រើនហ្នឹងមិនចឹងដោយសារធ្លាប់ធ្វើហើយហ្នឹងតែជាទូទៅពេលដែលប្រឡងគឺដាក់លំហាត់ណាដែលសិស្សអត់ទាន់ឃើញហើយបើសិនជាសិស្សហ្នឹងចេះធ្វើដែរអាហ្នឹងបានតែសិស្សហ្នឹងគឺពិតជាចេះមែនអញ្ចឹងពេលដែលយើង train model របស់យើងក៏ដូចគ្នាដែរពេលយើង train model របស់យើងពេលយើង train គឺយើងដាក់ data មួយទៅហើយដល់ពេលយើង evaluate យើងដាក់ data ផ្សេងមួយទៀតតែអត់តន់ដាក់មាននៅក្នុង training set ហ្នឹងប៉ុន្តែនេះដោយសារខ្ញុំគ្រាន់តែចង់ឲ្យយើងស្គាល់ familiar ជាមួយនឹងអាហ្នឹងទេអញ្ចឹងបានអានេះ train នៅហ្នឹងហើយយើង evaluate នៅជាមួយនឹង data ហ្នឹងទៅដែរគ្រាន់តែថាយើង evaluate អញ្ចឹងយើងដឹងថា model របស់យើងអាច learn ពីទិន្នន័យហ្នឹងបានហើយ it make sense ដែលវា100% អញ្ចឹងដោយសារយើង train យើង evaluate ទៅលើ training set អញ្ចឹងវា should be like that okay yeah so yeah actually all of these things so we have a lot more to discuss about this in the machine learning course actually because this is an NLP course and this is just like a thing to apply for our what we should learn in this lesson is about text classification. That is why I introduce you to this like classification technique, right? And we have a lot more to discuss for this actually because we have There is another course called machine learning that we will. It is a course in a master degree class. So in that class, we talk a lot more about this. Okay, so is it good for everyone? We can continue.
Yes, teacher.
I will share this code as well. Yes, any question? What do you want to ask?
Accuracy តើប្រមាណដែលយើងអាចកំណត់ថាវា the best rating
accuracy rate is between 0 and 100 if we talk about percentage.
But the best rating for the accuracy that they accept
It is 100. The more the better. Okay, so I will share you this code. Google Colab for except 4.3.2. All right, yeah. So we can continue. So now let's talk about multi-class classification, because what we have learned so far, it is just a classification that produce only two outputs, like two values output, positive and negative, right? But for classification, we can have like multiple classes as well. For example, like emotion detection. This one is NLP as well. Like if you have a status on Facebook and you would like to know like the emotion of the writer, if the status, if their status illustrates like sad, happy, or angry emotion. Okay, so the input is a text and the output is the emotion, is the type of emotion. So we have like not just two types of emotion, we can have like more than two types of emotion. So it is called a multi-class classification. Especially we see this in outside of NLP, we see in like image recognition, object recognition, image recognition, in weather forecast as well, because we like actually in Cambodia we don't have a lot of types of weather, but like for example in Europe we have all like many more, like for example it can also snow. So it is also an example of a multi-class classification. So what can we do for this case? Because what we have so far is just like a 4-binary classification. As for our cost function as well, you can see that this is purely for binary classification, because we expect that the label, the output y here, only like the possible value can only be like a 0 or 1, right? So for multi-class classification, we can do something like one versus many technique. All right. So you can see here that in our data, we have 3 classes, right? In different colors. So we have the blue, the red, and the yellow class. And what we can do is that we can convert it into binary classification, right? So we can create like 3 models, 3 binary classification models. The first model, we consider the blue class to be our positive class, and like the classes which are not the blue, all the data points that are not blue, we consider them to be negative class. Okay, so we have this one, we have this data set. And then we can just train one model in order to classify this data. You can see we have this decision boundary in order to classify these two. And at the end, we obtain something like this as an output from our hypothesis, right? And again, this one can be considered as a probability that the input data belongs to the positive class, right? Belong to the blue class. This is a probability that the input data belongs to the blue class. A similar thing for red class and for yellow class, we create two more models. This one, red class is positive, and this one, yellow class is positive. The other data points will be considered as negative class. And then we train like two more models, and we also have the output. So you can see we have now, because we have three different models, we have three different outputs as well. And each output corresponds to the probability that it belongs to that class. And so if you have a new example, we have a new data point. So we will obtain three values, right, from the three models. So how can we know like the data point belongs to which class? Of course, we can just look at the probability, which one has like the highest probability. That one is our answer. For example, in this case, you can see that H1 from model number 1, the output is 0.8. This is the highest among the three. So we can say that this input data belongs to the blue class because the probability is the highest among all three. Do you get the idea? So the drawback here is that if you have a lot of classes, you have to build a lot of models as well. Let's say that if you have 100 classes in our data, we have to build 100 models. And we have to do like 100 training as well. And for each training of each model, we have to try to do the fine tuning to do the configuration individually. So it will take us a lot of time in order to build like a perfect collection of models for multi-class classification in this way. Okay, yeah. Question for this one? Toàn này nữa, toàn đấy.
Sẽ toàn nó khổ.
toàn cái này.
Họ vốn như mình bay class này là cụ đi class po blue po red po yellow យ៉ាងទៅនៅពេលយើងបែកមួយខ្លះដូចវាមាន hypothesis របស់វារៀងៗខ្លួនមែនលោកគ្រូ
ហ្នឹងហើយមាន hypothesis របស់វារៀងៗខ្លួន
ប៉ុន្តែអាហ្នឹងវាតែ linear ទេមែនលោកគ្រូ
អាចជាអីក៏បានដែរអាចជានិយាយទៅដូចជា hypothesis ដែលយើងអាច apply បានជាមួយនឹង binary classification ដែរ
បានលោកគ្រូតោះ
សំខាន់ណា binary classification បើសិន multi class classification បើយើងធ្វើតាមរបៀបហ្នឹងគឺ បើសិនជាយើងមានប្រមាណ class គឺចំនួន model របស់យើងគឺស្មើទៅនឹងប៉ុណ្ណឹងដែរតែក្នុងករណីនេះមាន3 class យើងត្រូវបង្កើតជា3 model ផ្សេងគ្នាដែរហើយដោយសារក្នុងមួយហ្នឹងឃើញយើងយកតែមួយទេធ្វើជា positive class តែផ្សេងទេយើងយកទៅធ្វើជា negative class អញ្ចឹងដែលតែយើងដដែលហ្នឹងប៉ុន្តែឥឡូវវាខ្លាចទៅជា binary classification problem វិញទេយើងអាចធ្វើដល់មុនអញ្ចឹង ហើយដល់ពេលចុងក្រោយមកយើង combine អានឹងចូលគ្នាមកហើយ ដល់ពេលយើងបានទៅជា result ហើយយើង compare result គ្នាចំពោះគ្រប់ model ទាំងអស់អាណាដែលមាន output ខ្ពស់ជាងគេយើងយកអាហ្នឹងជា correct class របស់យើង Okay, yeah. So I hope it is okay for everyone. We can look at the exercise.
លោកគ្រូសូមសួរមកទៀតលោកគ្រូអាចជួយបញ្យល់មិនបានយើងដឹងអា hypothesis របស់ H1 ស្មើប៉ុណ្ណឹង H2 ស្មើប៉ុណ្ណឹងអត់លោកគ្រូ
You mean this value?
បាទលោកគ្រូ
This is just an example. Like after we train our model, we obtain the parameters, right? And then we can just choose one input, then pass it to our hypothesis, and it will produce an output. So this is like just an example. Like for some output, probably for H2 it is higher.
លោកគ្រូ
This is just an example, like for one input. Okay, yeah. Like right here, maybe the input is around like because like H1 is high, maybe it is like right here. Our input is right here. Okay, so if we pass this input, so we have a H1, H2, right? So we pass the input to the first hypothesis, it can produce like 0.8, and when we pass this to the second one, 0.1, the third one, 0.5. So we can say that H1 produced the highest probability. So this one belongs to the blue class. And probably we have like one more, like let's say like right here. Maybe for this one, H2 will produce the highest instead. Okay, yeah. So now exercise, another exercise, 4.4. So this one is a multi-class classification problem. And if you look at the data, you can see that the label can be the value of the label 0, 1, 2, and 3. So we have 4 different classes. So now we would like to build a classification model to fit this data. So if we use this technique, it means that we have to build 4 different models. So the first model, we consider class 0 to be our positive class. The second one, class 1, positive class, and so on. So we have to build 4 different classes, 4 different models. Okay. So, yes, we can do it together then. NLP, there is it. Okay, so I will copy from 4.3.2. So this one, it is called 4.4, right? And again, this one, the data we can upload to Google Colab. I just change it to 4.4. You see, so we have only two input features, and now the label. The label is, you can see it is not just 0 and 1 anymore. We have like 0, 1, 2, and 3. So let's try to plot it as well. Okay, so H1, H2, and two more. When the label is equal to 2 and 3. So we can use like maybe green and also yellow.
You missed W at the end of yellow.
Okay, yeah. Maybe yellow is too hard to see. Maybe orange. Okay, yeah. So you see, this is the structure of our data. So yes, and for this exercise, we have to choose our own hypothesis, and you can see here that it is linear separable, right? So yes, to make it simple, we can use like the hypothesis with the linear decision boundary. All right. So hypothesis the same, cost function the same. Training our model also the same. We don't have to change anything. The feature scaling. And then right here. So what can we do? Okay, we don't have to create TX3 and TX4. Okay, and TX is just this. What we have to do here is to change Y instead, right? Because like originally Y has 4 classes, 0, 1, 2, and 3. So we have to change it so that we have only 2 classes. So we have to have, because we have 4 classes, so we have to have 4 different data set as well. We have to create 4 new data sets. So what can we do here? Maybe I can remove everything here. Okay, so maybe I say I write something like ty0. So it means that this one class 0 will be considered as a positive class, and the rest will be considered as the negative class. So what can we do for this one? So we have to change, right? For value 0, we have to change to 1, and for value like 1, 2, and 3, we have to change to 0. Maybe I can write something like watch dot in order to affect the maybe we can, how do we clone? Maybe I have to Google a little bit. PyTorch clone tensor. We have torch.clone. And then we input the tensor. Okay, so it is very simple. So yes, we can use this one. Torch clone ty, right? Because we don't want it to affect the original ty. And then we can write something like ty0, all the values ty is equal to 0. So where like the elements in ty that are equal to 0 will be changed to 1. And the value that are not equal, the values that are not equal to 0 will be changed to 0. So let's try to print out if it is correct or not. So ty0 and ty. So let's say we print out only the first 20 element. Okay, you see, so 0, 0, 0. So the fourth one is 1 because the first one is 0. Okay. So if it is 1, 2, and 3, it will be changed to 0. So it is good. Okay. Yeah. And then we can just use this one to train our model instead. So what can we do? We can just call the train model. So th for 0 is equal to train model th and then ty0. Oh, last time we do not put ty as an argument. Okay. Actually, we have to put ty as for argument because yes, last time it works because it considered ty to be the global variable actually. So let me change a bit for 4.3.2. Actually, for the train model, we should include ty as an argument as well. So this one we have to include ty, and this one we have to include ty as well. Okay, so now let's get back to 4.4. Right here, we should include ty as well. So right now we can use a ty0 instead of ty. And after that, we can evaluate our data. So let me copy from here. Okay, so to compute the accuracy rate, and we can do something like tz0 is equal to htx h0, right? And then let's try to print the accuracy. Accuracy tz0 ty0 multiplied by 100. Okay, yeah. Yeah, you see, so the accuracy rate is 83.67. Okay. So now we can just have to train three more models for when we consider like a class 1 to be positive class, one model, class 2 positive class, another model, and the last model when we consider like class number 3 to be the positive class. Okay. So it might be a good idea to use a loop because we don't want to write the same code repetitively 4 times. Right? So we can just use a loop. So like maybe for C belongs to class in the range 4. So C will be from 0 to 3, right? 0, 1, 2, and 3. And then I can, yes, I can do something like T8 is equal to, I create one list in order to store all of the parameters that we have trained. Yes. And here I can change a bit to something like T by C. T by C. And here it is equal to C and not equal to C, right? And then T8C and here's C as well. And after the training, I will append it to the list T8. Yeah, and that's it. So, so let's try to, okay, so I will print something right here, like training model or class C, right? And then this one accuracy rate that we can just try to show it. All right. Yeah, so that's it. So let's try to run it again. You see, so now we have trained 4 different models for class 0, for class 1, for class 2, and for class 3. And you can see the accuracy rate of each model like respectively. So probably like class 0, it can be a little bit improved. For class 2 and for class 3 as well, because the accuracy rate we obtain only around 77%, so it can be improved. And for class 1, it is more than 90%, so it should be okay. Okay, yeah. So now we have trained all of the models. So now let's try to combine all of them together to create like just one big model in order to classify our data. So here we can do something like what can we do? Yeah, we can do something like this in order to evaluate our model. So yes, we can also do another loop for C in range 4. We can try to, yes, maybe here I can just TZ, create one list called TZ, and then just to store all of the output from the 4 models. So TZC is equal to H, TX, and then TAC, right? We will output our the output from each model, and then we append it to TZ. Here is TZC. All right. So now TZ is a list with four values, 4 elements. Each element is the output from each model. So now in PyTorch, we can combine everything together. So like TZ all, maybe I can call it something like this, is equal to torch dot, I think it is called a stack. Let me check if it is correct or not. So PyTorch stack. Okay, so the input is a list of tensor, and then the output is just one tensor by stacking or by combining all the tensors together. So this is the correct function to use. This is a new one, so it is called stack. I can just call stack TZ and dimension. The dimension that I want to stack is so the output is m by 1, right? For each output. So let's say we stack the second dimension. So dim is equal to 1. So now let's try to print out the size, the dimension of Z all. Right, you see, 300 and then 4 by 1. Okay, because this is, or maybe we can just use concatenation because it is 2-dimensional already. Okay, let's concat instead. Okay, yeah, this one is good too. Right. Because the output from each model is 2-dimensional already. I forgot about the second dimension, which is, it is only 1, but it is also 2-dimensional. So we can just use concatenation instead of stack. Okay, so that's it. So this okay. So the final result that we obtain is just one tensor with this dimension, 300, and the second dimension is 4. So you can see, imagine that we have 300 rows. So each row corresponds to each data, to each example, and the column is the result from each model, the probability from each model. So what we want to know is which one is the highest, right? So in PyTorch, we can use something like argmax. Okay, predict is equal to torch dot argmax of TZ all, dimension 1.
Sir, can I ask a question?
Yes.
So it will take the highest value of the 4 value by row, or it will take the highest value of all the data?
Let me draw you the. Okay, so here is TZ all, right? TZ all, what we have is that we have this kind of table. So each row is the example, right? So 0, 1, 2 until m minus 1. M is the number of examples. And the columns, we have only 4 columns. 1, 2, 3, and 4. Right? So this one are 0, 1, 2, and 3. So the first column is the probability output from the first model, which is corresponding to the class 0, right? And this is corresponding to class 1 and class 2, class 3, and so on. So we would have something like let's say this one is 0.8, this one is 0.2, 0.5, or 0.9, for example. So what we want to know from this is that we would like to know which columns contain the highest probability. So for example, for the first row here, we would like to return 3, right? So it means that the first example, our model, our combined model, we can predict that this input belongs to class number 3, class 3. Okay, yeah. So in our code, we use argmax instead of max, because if we use max, it will return 0.9, which is not very useful for us. We don't know like which class this 0.9 value belongs to, right? So what we want to know is not the value itself, not the maximum value itself, but the index corresponding to that value, because the index here is the class, right? That is why in our code we use argmax instead of max. Okay, yeah. And then we can just compare it with the real output. So we can do something like predict is equal to T5. And one more thing, the output from this function argmax will be of type long. So here is tensor m by 1, or maybe just m, of type long. We can also try to print out the size. And predict. Maybe the first 20, maybe the first 5. Okay, you see. So we have now because we apply argmax, so we will remove one dimension, and we will what we have left is only one dimension. Okay, so only 300. And you can see here, this is the index of the highest value of each row. Yeah. And if you look at y is 2-dimensional, right? Okay, y is 2-dimensional, so probably we should just convert it to 1-dimensional, and then also convert it to long as well. So we can do something like this. So accuracy or ACC is equal to predict equal to our ty, and then we convert it to just 1 dimension. So we shape -1, and then we convert it to long. And then we can just sum it and divide by the total number. Okay, so the total number, I think it is m, right? We define at the beginning, no? Here m. Okay, we have already defined m, so we can just use m here. Here we can use here -1 or just m. Here divided by m. Okay, and finally we can just print out the final accuracy. Yeah, that's it. Okay, so the final accuracy rate is 97.33%. We combine all the four models together. Yeah. Yeah. Yes. What is the question?
My question is, so it is not possible that the final accuracy would be lower than the maximum accuracy that we mix between the different model. For instance, the first in the first model, no, the second model is 96.3. So it would not be possible that if we combine all the model, that the final accuracy would be lower than this one, right? Or it can be lower.
We cannot know in advance. It depends on how our model separate the classes.
Okay.
Okay, yeah. So you can see that it can be improved. Maybe you can do the fine tuning. Yes, because right here in this block, we use the same setting. We use the same configuration for each module. So probably you can try to separate the training. Like you can use a different setting for each module. Like for the second one, maybe it is good enough already. But for the first one and like for the third, and for the last one, maybe you can train a little bit more in order to gain a higher accuracy for the models. And then you can try to evaluate like the combined models together to see if the final accuracy increases or not. Okay. Any other question? So we can conclude our lesson number 4.
Teacher, normally after we calculate the accuracy, should we do some testing on our model as well? Like we take the other data set and test with that model?
Yes.
Okay.
Yes, that is like the real way in order to do this. Actually, if you have our data set with like 300 examples like this, like before we do the training, we should divide it like maybe like 250 examples as the training set, and we keep like 50 for testing. So when we do the training, we use only 250. And then at the end, we try like to apply our model to the 50 examples that the model that the model has not seen yet, to see if it works with the new data or not.
So normally it based on the old data, right? When we do testing, like if we like the data is not like, I mean like the form of data is similar to the training data, right?
Yeah, yes, the same structure.
Yeah. I mean
that is why when you do the division, I mean like to divide into training set and test set, you have to make sure that the structure in the test set and in the training set should be like similar. Especially like in this example, we have 4 classes, right? So you have to make sure that like the classes are balanced. Like we have approximately the same number of examples in each class, both in the training set and in the test set. If you would like to divide into 2 subsets like this.
Okay, teacher.
Okay, yeah. So I think we only have 10 minutes left. So we can try to conclude. We only have like 2 more slides. So so now we will get back to text classification. So how can we use this classification technique in order to classify the input, which is a text, right? So yeah, so let's see this one. This is an example of body classification for a movie review. So the input is a body of text, and we want to classify if the review is negative or if it is positive. So this is a body classification. So first, we would like to create input features. We have to, it is sometimes called a feature extraction from our text input, right? And what we usually do for creating input features for text input is that you can see right here, it is just an example. So we would like to create 6 features. So feature number 1 is it is just the count of all positive words in the review. So right here, maybe you can define by yourself in advance, like what are the positive words. You can see in this example, like H1, you can see like the word great, nice, enjoyable, they are all positive words. So we can just count like the number of positive words. So let's say that here 3. So H1 is equal to 3, right? And then the second one is negative words instead, the number of negative words. So like a hockey, second rate. So here H2 is equal to 2, for example. And then the third one, the third feature, only 1 or 0. If the review contain the word no, so H3 is equal to 1. And if it like the review does not, if the input text does not contain the word no, it is 0. Okay, yeah. And H4 is the count. We count the number of pronouns, like I, me, you, something like that. And number 5, the question mark. We count the question, no, not count, just to see if there exists a question mark in the review or not. Yeah. And number 6 is just to consider about the length of the review, right? So we use something like a logarithm of the word count of in the review. Okay, so we have something like this. So you can also define your own features. Like it depends on the application. Like let's say that if you have something like in this exercise about spam email to detect if the input email is a spam or not, probably you have to use different features. Okay, yeah. So after we extract the features, we will obtain something like the data set with like 6 input features. And then the output is just like 0 and 1, right? Because we have 2 classes, binary class and, sorry, positive class and negative class. And then we can just use the classification, like logistic regression that we have learned so far in order to fit the data. All right. So the thing is that we have text as input. And from the text, we extract feature. Right? And then we train it. This is the process. Do you get the idea behind this one? តនេះបងប្អូនកន្លែងហ្នឹងសម្រាប់យើងប្រើ classification សម្រាប់ text វិញ
អត់តន់គ្រូ
អត់តង់ឡើយណាឥឡូវយើងមើលយើងធ្វើតាំងពីដើមមកម្ណាម្នៃហ្នឹងគឺបានន័យថាក្នុង data set របស់យើងមិនត្រូវមានជា input features របស់យើងជាលេខស្រាប់ហើយមិនចឹងយើងមាន x1 x2 ជាលេខទៅហ៎
បាទលោកគ្រូ
ចាឥឡូវបើសិនជា input យើងជា text ធម្មតាវិញធ្វើម៉េចយើងបានលេខហ្នឹងមកដើម្បីបានលេខហ្នឹងបានតោះតែយើងនេះគេថាធ្វើអា feature extraction នេះចឹងដើម្បីបានជាលេខហ្នឹងដូចអានេះគឺ feature មួយចំនួនដែលយើងអាច collect បានពី text ដូចក្នុងករណីនេះគឺរាប់ចំនួន positive word រាប់ចំនួន negative word រាប់ចំនួន pronoun អាហ្នឹងគឺជារបស់ដែលយើងជា feature ដែលយើងអាច collect បានចេញពី text ហើយដូចក្នុងនេះ example នេះគេមានតែ6 feature ដែលគេ collect ចឹងគេបាន6 value ហ្នឹងចឹងតែយើងបានយកអាហ្នឹងធ្វើជា input features របស់យើងដើម្បីយកទៅ train classification model របស់យើងអូខេ
បាទលោកគ្រូ
Yes. So now you can try with exercise 4.5. So this is a data set about spam email. So we have a collection of emails, and some are spam, and some are not spam. And here, actually, the data set is not like we have already extracted the features for you. Let me show you the data set. Okay, so here's the data set, spam-based data.csv, and you can see we have like 58 features. So each row represents an email. As you can see, we obtain like 58 values from each email. And you can see the detailed information here. Okay, these are all the 58 features. Okay, they count the word make, they count the word address, they count the word all. These are all the words that they count. So each of the count is considered to be one of the features. And also they count also the characters. All right. So these are the features that they extract from the email. And if we look at this data set again, you can see, so from this one until the end, they are all of the features. And the last column is the label. So one, it means that it is a spam. Right? One is spam. Yes, one is spam, and 0, it means that it is not a spam. You see? So we have a lot of data. Okay, yeah. So you can try to train this data in order to create a classification model. And if possible, you can try to test it with a new email to see if it is a spam or not. So if in order to test it with a new email, you have to extract all of this feature from the email. Okay, and in order to extract it, you can just follow this information. This is the word that you have to count in the email in order to obtain the feature. All right. So yes, question for this one?
Sure. Data 4.5 in the far right.
Yes, I haven't uploaded it yet. I will upload it. I will create an assignment because this is your final assignment. Right? I will create an assignment and I will upload the data for you.
Teacher, one more. Do we have a exam?
Yes. So actually, this is the last week according to our calendar. This is the last week of actually, I would like to have one more session, but I'm not sure if I could fit it next week or not. But the thing is that for the final exam, it will cover only from lesson 1 until this lesson number 4. So I will inform you about the schedule of the final exam later.
Okay, teacher.
And again, the final score is composed of only 2 components. The first one is the assignments that we have been doing so far, and the final exam. Okay, so it is very important that you submit your assignment. And this is the last assignment, exercise 4.5 here.
assignment 4.5 យើង apply ពួក hypothesis នៅខាងលើនោះមែនលោកគ្រូ
ហ្នឹងហើយយើងចំពោះ hypothesis for the hypothesis you can try to choose one yourself. It can be the linear, the one with the linear decision boundary or the one with the polynomial one. It's up to you. You can do like some experimentations to see which one is like better.
បាទ
and you can see here that for this data set, we have a lot of input features, 58. And one more thing that I want you to check as well is it is called a batch or mini batch. You can see that in the previous example, we have only around like 100 example, like m is equal to 100 or maximum 300, right? So for each iteration, we train 300 examples in order to update our parameters. But in this data set, we have like thousands of examples. So if you do the same thing, yes, it should work, but it can take a lot of time because you have a lot more examples in your training set. So another way is to do the mini batch. So it means that if you have like 1,000 examples in your data set, for each iteration you train like, for example, like 100. Right? So it means that 100 per iteration. So if you train 10 times, it means that you have trained your complete data set, and it's called epoch, this term. So yes, what we have done so far is that one iteration, one epoch. But we can train in mini batch. Like if you have 1,000 examples, we train 100 examples per iteration. So it means that in order to have trained one epoch, we should do like 10 iterations. Yeah. So this is the terminology. So you can check by yourself. If not, you have to do like just like before. So you have to train everything in each iteration, and just evolving beforehand, you can have it will take a lot more time because you have a very big data. Okay, yeah. Okay, so I think it is you have another class, so maybe we can stop here and just. So this is your last assignment. To summarize, this is your last assignment, and we will have an exam. Yes, probably next week or the week after next week. I'm not sure yet. I will inform you about the schedule of the exam.
Thank you, teacher.
Okay, yes. So yes.
Thank you, teacher.
Thế là cũng
Thank you, teacher.
Yes, goodbye.